Hey, what's going on, everybody? This is Sean Jackson, owner and operator of Cozy Home Services here in the Lansdale, Montgomery, Bucks, and the Philadelphia area in general. Today, I'm going to take you along as we do a heating tune-up on a gas furnace. All right, y'all. So here we have a Lennox, pretty good model. This is a 80% gas furnace. You can always tell what percentage the furnace is by the flue pipe that's exiting. This is a metal flue pipe, which lets you know that this is an 80% gas furnace. So what we're going to do is we're going to pull this apart. We're going to get it cleaned. We're going to do a safety check, and we're going to make sure that everything is operational for this upcoming winter. All right, let's do some work. All right, so whenever I start off on a gas furnace, the first thing I want to do is start from the top, and I'm going to work my way down just to make sure that I don't forget anything. So we are going to start here. So just a little bit of background on this furnace. This is a 2011 SL280. If you want to take a look at this data tag, you can see SL280. SL is the signature line. 2 is a 2-stage furnace, and it's an 80%er. So that's really how you tell. With Lennox, you could tell the age of the system by the second set of numbers, which is this 11 here. So this is a 2011 model. So the first thing we're going to do is, again, we're going to start from the top and work our way down. So I'm going to start right here at this inducer capacitor. So this right here is your inducer motor. It's responsible for pushing all the toxic gases out of your home. So the first thing we want to do is check this capacitor and make sure that it is still the correct rating. You got to remember, these things are batteries. Like any battery, even when it's not running, it has potential energy stored inside of it, and it is a risk of shocking yourself. So the perfect way to do it, the old school way, was to just put a screwdriver across the tube. But you know, obviously we've evolved since those days. So I'm going to set my meter to ohms, and I'm going to go across the connections and just make sure it reaches 0. And then I can switch to microfarads and I can test this. So as you can see, this is reading 3 point up. I missed it. I grabbed the camera. But this thing is reading 3.9. And this is a 4 microfarad capacitor. Capacitors usually have a fudge factor of about 5 to 6%. So this thing is still good. All right, that is fine. On these SL 180s or 280s, most of the Lennox's 80% furnaces have this pressure tube right here. So let me make sure you guys can see. This is a pressure switch. The pressure switch is a safety. It is to prove that your inducer motor is indeed working. Because like I said, your inducer motor is pushing all of your toxic gases out of your house. And obviously, you need to have some safeties in place to make sure that your toxic gases are being pushed out of your home. That's where your pressure switch comes in. It just proves that this motor is under enough pressure to be able to push the gases out of your home. So what we're going to do is we're going to pull off this tube, and we're going to make sure that it's clear, it's not clogged, and there's no debris in it that can, for some reason, be setting off this pressure switch. All right, gonna get a look in there. Make sure that that port is clear. That is typically where you'll end up seeing a lot of failures on these units, is this port right here. It will get clogged with debris and dirt coming from the inducer and from your exhaust. So you can pull this off, go through it. That is good. And then I usually like to take a little piece of wire. Take a little piece of wire and go ahead and shoot it through there and just make sure that that port is clear. So now we know that the inducer capacitor is good, and we know that the pressure tube to the inducer port is clear. Next thing I'm going to do is I'm going to move my way down to the burner box. So let me set you guys up. Have a look look at this. This is your burner box where all your flames and all the magic happens. So I'm going to remove the door. Or the door will remove itself. All right, now we can get in here and get a look at this motor. So as soon as I come in here, one of the first things I'm going to do is I'm going to clean this flame sensor right here. This flame sensor sits inside the flames, and the job of the flame sensor is another form of a safety. Its main job is to prove that the flames are making it all the way across. Your flames start here on this side, and with your hot surface igniter, it shoots over all the way across, and this just proves that the flame made it all the way across. So you can see, I don't know how well you can see that in the camera, but it sits in the flame and it gets nice and dirty. And if this eventually gets dirty enough, you will not be able to sense flame and it will shut your system off. So we're going to grab a steel brush and we're going to clean this off. Gotta get my big bald head in there. Alright, so clean this bad boy. Make sure it's looking spick and span. Alright, so now that this is clean and ready to go, I'm going to sit it off to the side. And the next thing I'm going to do is I want to get my inspection camera out and I'm going to inspect these burners. So this is a sealed chamber, so it's a little hard to get in and see these 4 burners. You really need a nice microscopic camera. So I'm going to get in there, and while I also have my camera out, I want to get inside and have a look at this heat exchanger and see if I can see any wear and tear on the metal. One of the best ways to always get inside and see a heat exchanger is to go in through the high limit switch, which is located right there. You can the high limit switch is another safety. You're getting the theme here. It's all about safety when it comes to fossil fuel appliances. So this sits right near the burners, and the job of your high limit switch is exactly kind of how it sounds. It's to detect high limit. So your furnace has a temperature that is not supposed to get warmer than, and that's a little safety there. And if this little safety here senses that your temperature is hotter than it should be, it will shut your system down. And again, it'll give you an error code. Here's my handy dandy inspection camera, and here's my tube that goes along with it. Sticking this in there. And that's what I'm looking at there. These are your burners. These are where the flames shoot across and into your heat exchanger. So I am inspecting these burners for any massive amounts of corrosion, spider webs, or anything that looks unsafe. So these burners are a little bit weathered, but honestly they're in pretty decent shape, being that the system is 14 years old. So I can take a look in there, and I can see how my camera is fancy, so I can spin it around, and I can get a look at what's going on inside of there. I want to get it all the way to the back bend. Oh, you see that? Some corrosion. When these heat exchangers come fresh out of the box, they are a galvanized steel. So they're coated with a nice shiny material. So, but anytime you have flame and, you know, moisture and everything with the byproducts of combustion, it will start to corrode and eventually it will crack. So that is what I'm checking for, because I want to make sure that there are no cracks in this heat exchanger. So, alright. So I do see a lot of corrosion in there, as you can see. I'm just pulling the camera back and then you take a look at that. Ooh, let's have a look at, so the way these heat exchangers are designed, they're designed as a serpentine style clamshell. So they take two pieces of metal and they clamp them together in the S form, and your flames shoot through these tubes. So obviously when the flames hit that back of that heat exchanger is when you're typically going to see the most heat and the most corrosion. And also typically where you'll see your cracks. And these are the tubes that the flames shoot inside, as you can see. So far on this model, the heat exchanger does have some few concerning spots. When I look inside there, I don't want to see any deep rust or any cracks. Anything like that is always a bad sign, because like I said, that metal comes nice and shiny out of the box, and over the years, as that metal wears away, you will be exposed to cracks. All right. With that being said, I'm now going to check the blower compartment. And here is your blower compartment. So right up front, we have your control board. Now this controls not only your heat, but your AC as well. This is your full furnace control board. Where you have your thermostat connections, you have your high voltage connections, you have your transformer, and then all your safeties and everything are tied into this board, and all your motors are powered from this board as well. So you always, every time you pull this off, I want to check and make sure all the wires are, I just tug on these wires, make sure nothing's loose, all the connections are straight. I want to check this board and make sure I don't see any arcing marks, like any black, kind of like, arc marks from, electrical overcurrent situations. But this board seems to still be in good condition. Next thing I'm going to do is I'm going to get my hand in here. I'm going to snap a photo of your blower wheel. I want to make sure that that has no corrosion on it or any buildup of dirt. That's the blower wheel. So looking at that, that looks pretty good. Let's zoom in, make sure there's absolutely no dirt on there. A small amount of dirt is okay, but the more dirt that builds up on that blower wheel, it kills the efficiency and it kills the airflow, because it takes up the surface area that the blower wheel needs in order to throw the air. I'm also going to reach my hand in and I'm going to grab the shaft of the blower wheel and just try to wiggle it, see if it wiggles back and forth or forwards and backwards. And I have no wiggle on this blower, so that lets me know that that blower is in pretty good shape. All right, and as far as your blower compartment, those are the main things you need to do. That's an ECM motor, which is an electric computated motor, which means that this blower wheel does not use an external capacitor. Everything is built in to the blower's module. I don't know if you noticed, but I did not put the flame sensor back yet, because before I start to put everything back together, I am going to do a full clean of it. And I'm going to get my shop vac out and suck out all the dirt, suck out all the bugs, and make sure that it's looking nice and presentable for the customer. The thing that almost 50% of my calls are concerning: your filter. Yeah. I know some of y'all are like, what's a filter? I got a filter. Yes, you do. Every system has a filter. And they lock this one with a screw. Hold on. Let's go ahead and pull this bad boy out. Let's see what we got. Sometimes they're a little harder to get out. There you go. And this is their filter. Honestly, this filter is in pretty good shape. It's not terrible. But these small 1-inch filters, they should be changed every 1 to 3 months. Not every 6 months. Not every 9 months, not every 8 years. 1 to 3 months. That's all you need. And this needs to be replaced. So even though this is still in good shape, we're gonna go ahead and replace it because this has been in there since May of 2024. Wow. So he must keep a really clean house. But let's put it in. I'm gonna write my date on it, like always. As far as this furnace goes, those are the main things that need to be addressed when you are breaking the furnace down. You need to check the burner box, you need to clean the flame sensor, you need to check all the capacitors, you need to make sure all the drain lines are clear, and you need to make sure your electricals are secured and your blower wheel is clean and there's no play in the shaft. So now that we've established all of that, we checked our heat exchanger, I'm going to put things back together. I'm gonna get it out my shop vac and we're gonna do some cleaning. Good old Milwaukee shop vac. You can't beat it. I love this little bad boy. Wireless, battery powered, gets the job done. All right, so now we're gonna go ahead and test the system. When you are testing a fossil fuel appliance, especially a gas furnace, the main 3 things I'm looking for is temperature split. I'm looking for the amperages on these motors. I'm checking the flames to see the integrity. And I'm also doing a combustion test using my combustion analyzer. And this bad boy is gonna tell me everything I need to know about how the system's operating. So let's get everything hooked up and then we'll go ahead and kick it off. So I need to know my return air. So I have one temperature sensor that I'm gonna be placing in the return duct. I have another temperature sensor that I'm going to be placing in the supply duct. Most furnaces will already have a hole right here that lets you know that another technician was here already and did a combustion test. That other technician was me. I've been here for the last few years. This is just high temp silicone. You can just pull off. And then there's your test hole right there. So I'm gonna go ahead and get my analyzer and put that in there. What about the combustion analyze? The thing we're gonna be testing is the gas pressure. So here is your gas valve. This is a residual gas valve. You have 2 test ports. You can test the incoming gas pressure here, and you can test the outgoing gas pressure right here. 2-stage furnace, you should be looking for 1.7 inches of water column in the low stage, and you should be looking for about 3.5 inches of water column in the high stage. That is for natural gas, and that is for this appliance. But don't trust me though. If you ever want to know, you can always look at your system's data chart, and it'll tell you right there. You can tell you right there. Manifold pressure, 1.7 on low stage, 3.5 on high stage.
While we're here, I also want to show you another thing I'm looking for. This is the maximum outlet air temperature. That is 180 degrees. So if my air gets anywhere near 180 degrees, that is an issue. Another thing we're going to be checking is the temperature rise. This is the manufacturer's guideline on what they want the return air to the supply air to be. So on first stage, the air difference, the temperature difference should be between 25 and 55 degrees. And on second stage, it should be between 40 and 70 degrees. So as long as I have that, I know I'm good. I'm pretty fancy. I use a digital wireless manometer. This is my test tube. You want to turn it on first. First thing you want to do when you turn it on is go ahead and zero it out. Make sure that it's nice and zero. Remember exactly what size this is, but you just need a small Allen key. I'm going to go ahead and just crack this maybe 3 or 4 turns. And go ahead and cover up the test port. Multimeter. And I want to start off on the low side of the inducer motor. I want to see that inducer motor's amperage. Then I'm going to switch to the high voltage wire, and I'm going to test the blower motor's amperage. All right, the system just started up. So we're going to test and see what we have. Our hot surface igniter is kicking on. As you can see, that thing is glowing. I probably didn't show you on camera, but I tested that already to make sure the lines were proper. I'm going to check our inducer motor amperages, which are nice. Our flames have shot across. We're watching those flames. You want to come in here and watch these flames with me? I don't know if you can see. There you are. So I'm checking for that nice blue flame, and I'm watching for any wiggle in the flame as soon as the blower motor kicks on. Because like I said, those heat exchanger cells are sealed cells, and none of that air from that blower motor should be getting in, interfering with those flames. So we're gonna watch, make sure we got no wiggle. Blower's kicking on. Flames look good to me. All right, let's go ahead and start our combustion analyzer. Check our second stage inducer amps. Those are looking good as well. Now I'm gonna latch onto the high voltage line, and I'm going to check the total system amps. All I had to do is just divide the inducer motor amps, and that gives me my blower motor amps. Blower motor amps look good. I like it. My phone, let me check my manometer pressures. Those are good. All right, so we've got the system running. We've checked the flames. I'm going to now close the door. Let this system run for a good 20 to 30 minutes just to make sure that no sneaky issues persist. So far, this is my combustion test. I don't know if you can see it, but these are the numbers that I need to read to make sure that everything is going right with your system. I need to check your oxygen levels, your carbon dioxide levels, most importantly, your carbon monoxide levels. I need to see your efficiency and your excess air to make sure that this thing is getting enough air for combustion. The system has been running for 25 minutes now, and all of my pressures are looking good. My return air is about 77. My supply air is about 132. That is within the allowable limit. And if you take a look at my combustion analysis, all my numbers are still looking good. My carbon monoxide is looking good. My efficiency, my stack temperature, my carbon dioxide, and my oxygen. So I can officially say that this furnace is ready for a good winter. Never forget before you leave to seal back up this hole with high temp sealant. Get that back in there. All right, and that's good. All right, guys, and that's it. This furnace is ready to go. These customers should be having a good winter. Again, I'm Sean with Cozy Home Services. If you like this video, please leave a comment, like, and subscribe, and just join us along on the YouTube journey. And don't forget to schedule your heating tune-up.